In this video, we'll talk about input and output of a microcontroller. The text, you always see microcontroller, UC, alright, it means that it's microcontroller. Before going to input and output, I'll just talk about the power supply. The power supply has a VSS is negative, ground, VDD is a positive supply. Alright, what this means is, let's take a look in the Arduino plate, this is GND, this is a ground, and you have a V in over here, this is called a VSS. Alright, sorry, VDD. Alright, your VSS is over here, your ground. Okay? Remember that VDD is positive, you just remember that D stands for die, die times die equals to die square. Die square is undie, so you didn't die. You didn't die means that you are positive, good. If you have a breadboard over here, if you high it means plus is the red color one, alright. Low minus means the blue color one. If you just want to connect, you just connect the plus to the plus, alright. This whole stretch is just a plus, and then this whole stretch is over here is just the minus, and then minus is just connect over here. You can also connect over here, you can also connect over here. Be it anything, alright. VDD is the high, alright, it's your high input, alright. Or you can just take it as 1 or 0. 0 is the low one, and high is the 1, alright, if you talk about binary, alright. Normally between VSS and VDD, you require a decoupling capacitor to actually reduce noise. Why? Because the digital circuits produce an electrical noise, and the capacitor actually shorts this out and prevent affecting the other components to a certain extent. And in fact, this is just the purpose of the decoupling capacitor, is to reduce the noise and that's it, alright? Or reduce the electrical noise. The power supply, we'll explore this in the more detail later. So we're going to talk about the digital output first. Therefore, why is LED digital output? Because when you input into the Arduino itself, alright, there will be a light emitting, alright? Either it's output light or output nothing, alright? Later on we'll talk about it. For LED, the long one is a plus, the short one is the minus, alright? Call this the high, or you can call this the low for the minus, alright? The high is the anode, for the low is the cathode. So therefore it is called the diode, because it's a light emitted diodes. Because diode have the anode and a cathode. Therefore you need to connect it properly, alright? There is two ways in terms of connecting it, alright? So let's talk about it now. Just for you to know is that I'll skip some slides because it's just straightforward, just reading only. For Arduino, normally it will output at 3 mV. I don't know whether it's 3 mV or 3 volt. I should say that one pin should give out a 3 mV. What do I mean? These little stuffs are the pins. You have so many pins. These are all the pins. These are all the pins also. 30, 34, 53. These are all the pins. So the pin has 3 mV. Alright. And this is the diode. The diode has a 2 mV tahan. If more than that, you'll burn. Connect the pin to the diode and the diode to the ground. Then you are considering yourself as an active high. What do I mean by active high? It means that it is active when it is high. Aha. This LED to be high, you need a 2 mV. So when you active it, alright, or you send in a 2 mV, it becomes high. When it becomes high, it becomes active. So you have a light over here, right? But 3 mV is not in. It's too big for 2 mV. You will burn. So therefore, I have a 1 mV. So-called the resistors over here. Resistors can tahan 1 mV. Alright. If you wanted 3 mV, but why you attach these resistors behind the diode? Is because that. When you're talking about voltage, voltage is a potential difference. So this is 2 mV, this is 1 mV. Alright, so it's just a light, you know, it's traveling in speed of light. So when you on, vroom. Alright, talking about 2 mV and 1 mV all together. Alright, so therefore, so you can put resistors in front or behind of the diode is alright. Alright, repeat again, pin LED to the ground. It's active high. Why? It's because the pin will send a certain voltage to the diode, and the diode will light up, and that is why it's high. Because when it's high, when the diode is high, it will become active. Alright, high means that it is full voltage, 2 mV. Once it's full voltage, active. Alright, active means that it lights up. Okay, let's go. Active low on the other hand is VDD supply, diode, and then pin. It's the other way around, terbalik. As you can see, this LED is turning like this. Alright, this is the plus, this is the minus. Sorry, my fault. This is the plus, this is the minus. Alright, this diode over here is like this. This is the plus, this is the minus also. But it's in terms of how you flip. Alright, if you were to flip it like that, alright, this is also plus and minus, but because the anode and the cathode is different, or because over here this is the anode, this is the cathode. Hey, what am I talking? This is the anode, this is the cathode. So this is the plus, this is the minus. Alright. So when the plus connect with the plus, you have plus, minus, minus, so it's kind of smooth. Alright, if you were to connect in another way, where this is plus, this is minus, this is minus, this is plus, then things gonna be a little bit opposite. Alright, that's just the meaning of that. When you set a pin to ground, so you just connect it to ground, I believe, which is VSS, sorry, which is ground. Alright, so when you connect the pin, it's at ground, negative logic 0. So this means that you'll light up this stuff over here. And then when you supply a certain input voltage, you actually off the light. Alright, that's the thing. So this means that VSS is ground, so this is why at low voltages or high or low, right, 1 or 0, at 0 you're gonna light up. Okay, so when you high, you input a 1 voltage over here, I mean 1 millivolt. Alright, you're gonna light up, you're gonna off this light. Alright, so when high, it's not active. So when low is active. So when low is active. Alright, previously in the previous method is when high, then it's active. So be careful of the rearrangement of the diodes and how the supplies and the grounds are all being so-called arranged. Therefore, let's calculate the value of the resistance in the series. Calculation now. Let's go. So I say it's 3 millivolt. No, actually it's not 3 millivolt. It's 3 volt. Alright, it's 3 volt. Not from the pin, but rather than from the Arduino itself. Alright, so 3 volt will input into this system over here. This LED can tahan 2 volt. Alright, which is the potential difference. So therefore this resistors must tahan 1 volt. Alright, so how do we tahan this 1 volt? So 1 divided by 3 milliampere, what do I have? It's 1 divided by 3 divided by 1000 because it's milli. Therefore we have 333.33 so-called the ohm. Alright, round off, you can get a 400 ohm resistors. So 400 ohm resistors can tahan 1 volt over here. Alright, and that's it. This is just a calculation for your resistors over here. Alright, just take note that your voltage in series is adding up. Alright, if it's for current, it's just all the way straight. Alright, all the way is the same. There is a 3 milliamp over here, and there's a 3 milliamp for your LED over here. Alright, just take note of that. Just a simple calculation for your series system for your stuff. So then you know that this resistor is to prevent any burning, because if you burn it, the whole LED will spoil. Alright, so just to recap. What can the SEM3X drive? Alright, this is actually a very small system, I would say. It's supplied at 3.3 volt, so you need a 2 AA battery, because 1 AA battery is 1.5 volt. If you were to put 2, then you can just sum up run this thing. Alright, and each of the pin, as we say, is 3 milliamp or 15 MPa. I mean 15 MA. Alright, they can receive a current of 6 MA and or of 9 MA. Just for you to know about it. And it's limited to 130 milliamp for the total drive current. Alright, for all pins if you were to combine them all together. Each I/O line, meaning input output. Alright, I is input, O is output. So input output line. Alright, and it's the ODT, online termination. And what is it all about? Minimize the distortion of the signal. Impedance, if you remember the Z, talking about the resistors in terms of the capacitor, and then you have some angle if you still remember the calculation. Yeah, this is the impedance that we're talking about. Is somewhat same as the resistance, alright, of every location on the transmission line should be uniform throughout its length. So all the parts are all the impedance should be all same. Alright, if they are not same, for example, open circuit impedance, I don't know what the hell, and different material. Impedance, discontinuity means that your impedance aren't gum. Alright, for example, you have a 5 ohm, and then your impedance is 2 ohm, then definitely this is discontinued, because it must be always 5 ohm as it says, right? Because the impedance of every location on the transmission line should be uniform throughout its length. So it should be all 5 ohm. If you have a 2 ohm or whatsoever other than 5 ohm, then something is wrong. Actually say that the signal gets modified by reflection. I don't know how they reflect. It will cause distortion, ringing, and otherwise. Just take note that ODT, online termination, is always being embedded within the input-output line. That's all it is. And if you just take a look, this is the ODT, alright, and this is your driver, your Arduino, if you were to say that, and you actually send in with certain 10 ohms, alright, and there's a PCB trace. The purpose of the PCB trace, I would believe, I may be wrong, but I believe from what I take note of is there'll be a certain impedance over here. If this impedance somewhat fixed with the impedance over with the ODT, then you actually allow the receiver to light up or something like that. Alright, if otherwise, then it will not light up. Alright, if the receiver is, you're talking about diode, alright, or yeah, for example, alright. So therefore, yeah. For the PCB track impedance, preventing signal reflection, right, somewhat helps you to prevent unnecessary output, something like that. Alright, so if the impedance is together, is the same as your ODT, then okay, that's it, on. If otherwise, then no way, dude, no way. We have covered the power supply and the digital output. In the next video, we'll talk about the digital inputs and maybe some other codes. See you there.